Okay, so welcome back for session 15 of 120B to 20B. Today we're going to continue talking about HVAC systems, and in particular, start talking about air handlers and heating, cooling loads, and how we go through and use REV as a tool to go through and help us calculate some of those things. We'll also think about just sort of different heating and cooling strategies, because you really have a lot of options available to you. It doesn't have to be strictly this kind of heat that is coming out of hot air from an air handler, coming out of some sort of a heating system there. We can do all sorts of things that are much closer to the destination, and oftentimes you do want to do something like that, because for every different zone and every different load on the different zones in terms of the number of people, the occupancy hours, the kind of the heaviness of the use of those spaces, and even the type of use. Is it a steady, slow kind of use, or does it change and fluctuate very rapidly in the case of like a public room where hundreds of people show up all at once and then go away later? You often want to go through and control things a little more finely. So you don't have a single system, you can have kind of a combination of multiple systems together. So we're going to look at all those things together and hopefully answer some questions about how heating and cooling loads get calculated and some of the errors you get along the way. So we're going to go ahead and start though with just the whole issue of air handlers and where they can go and how we hook them all together. Where we left off last time is we ducted everything. We got some main ducts going back to some principal space, and whether that air handler is on the roof or is in the basement or is in a pit outside doesn't really matter a whole lot. They're all sort of valid strategies. The big issue with air handlers in general is though you want them to have availability of outside air, because you're going to replace some outside the recycled air with some outside air, bringing in some fresh air. So you'll always have some sort of a louvering system, someplace where you can sort of exhaust air that you no longer want and bring in new air to kind of replace that. Okay, but where they are is really going to depend on everyone's buildings, and a lot of people's buildings are quite nice architecturally. So if you're on a hillside, you may not want it up on the roof, or you may not want it in a very prominent spot. You may want to put it off to the side somewhere. And they're all sort of valid strategies. But let's just kind of take a look at air handlers and how we hook them together and really what some of our options are. So to go into that sort of section, what I'm going to do is basically, within the whole notion of modeling ventilation systems, okay, there's really the specific topic of air handlers, and there's a lot of different kind of ways of doing this. There's air handlers that are kind of, single zone, multi-zone, self-contained systems. There's all sorts of different sort of systems that are available, but generally, they have a different series of inputs and outputs to them. They have supply air that's coming in, that's the fresh air. Then we have the return air. Okay, that is the recycled air that is an input to the air handler. It will be combined with the fresh air, and then you heat it or cool. And then the output is just going back into the building, supplying air into the building. So let's just kind of take a look at some of these and sort of see how they can work. For example, let's go ahead and take a look at some of the air handlers that we have in these kind of sample Revit models and see if we can find one that looks similar to what we would like. So if I go on out there and I start with just downloading the files they were in session 13, but they're also in the session 15 folder now, depending on where you want to find them. I'm just going to keep on moving them forward. I had all sorts of different air handler location variations. And if we take a look at any of those, the air handler on the roof is probably the most common one. Let me go back to that one first and we'll take a look at that. Air handler on roof. Okay, let's go through and kind of take a look at how this all works. So the idea is basically we have some air handler on the rooftop that is connected, and maybe I'll start with that. The big thing we're going to start by doing is physically getting this thing connected. And that's always a little bit of a challenge, just because the ducts that you have coming into it are often kind of smaller than the openings on the air handler. So sometimes there's a little bit of work to make it all fit together. I'm going to go say ZF, zoom to fit, and we'll take a look at this air handler, for example. So this is an example of an air handler. It's pretty typical in terms of how things are set up on the outside. if you go through and take a look at it, I actually have this one hooked up incorrectly right now. I'll be the first to admit that. As I take a look at it, you can see it has a different series of inputs and outputs. And what's really going on here is, over on the far side over here, okay, this is supply air. It's basically an opening that's 44 by 37. It's quite a large opening right now. And we can go and resize that, but that's the way it's set up on this specific unit. As you go through and you download different air handlers from manufacturers for different sizes, they'll have different kind of openings and size configurations. And often what we'll have to do is come out and do some sort of transition to bring it down to the duct size that we need. Okay. The way this one works, it's a little bit interesting. That's kind of the supply air going out. I actually hooked this up incorrectly. Where I'm supposed to be bringing the return air in is up through the top and bring supply air into the side. I actually got it backwards when I was first doing this. But the way we go through and hook these up is pretty similar. Let's see if we can go through and even fix that or even take a look at this and figure out how we can do it. For this air handler, if you take a look at its properties, and this is the one that's just got a standardly supplied with Revit. Outside air handling unit, 6 square feet of coil. They have different sizes. They have everywhere from 6 to 8. As you go bopping on up to a much bigger one, for example, let's say one that's about 3 times as big. See, it got bigger, and the openings actually got quite a bit bigger too. What it's complaining about down here, well, it disconnected from the system. It says it no longer matches. I'll just say no to that right now. So what I want to sort of drive home is that these openings will go through and change based on the different type considerations or the type properties. I'll say cancel that. But a lot of these things are actually parameters that can be changed. So you'll see there's like a supply air outlet width, supply air outlet height, supply air inlet height and width, and return air inlet height and width. So they're all set up with these numbers like 44 by 37, 42 by 16. And if those numbers just aren't working for you, or based upon the capacity of the ducts that you're piping into it, you don't need that big an opening, you can change those things. And often that's sort of a useful thing to do. Because if you have a big old opening and a smaller duct, there's going to be some big old transition piece that goes between the two. And every once in a while, that becomes your problem. It's just making the difference between all of these different sizes. So, for example, on supply air outlet, right now it's 44 by 37. You'll see that to hook my duct to it, it actually took a very big reducer to go through and make that happen. Okay, but really before I go through and change all that, what I really want to do is do a little bit of systems analysis so that I can go through and figure out really how big this thing does need to be, and then how big the ducts would be that come on into it. In terms of physically connecting though, let me just kind of show you physically how you go through and connect one of these things. Although, well, let's go ahead and disconnect it. We'll try reconnecting it again. What I'm going to do is I'm going to just take out on this one these last 2 pieces. I'll even take out the last piece over here. Maybe even back this off a little bit. And I'm trying to connect these things. Space is definitely one of those things you have to play with. If you're going to have troubles anywhere, the problem you're typically going to have is, do I have enough room to make all the necessary elbows to get this thing aligned right, or taps to get it aligned right, and the reduction to go through and kind of change between the different sizes. So having a little extra space is definitely a good thing for you. But as you think about this, let's kind of talk about what it does do for you. If you choose an air handler like this, you'll notice that it has certain connections available to it. There's sort of the supply connection here, the supply connection here, and the input for the return air up on the top. And when you see connections that look like this, what's actually happening is it's offering you a little handle to let you pull something out, pull out a piece of pipe that is that same size as the connection. Okay, so it's a little bit hard to do in 3D, so I did not to do this in 3D. What I'll usually do is come in here. I'll show you how it's hard to do it. If I click on that, I can get a duct But what it's trying to do is somehow square it up to my current orientation, which is not very good. It's trying to make it kind of, since I'm coming at it at a 45-degree angle, it's got the duct rotating that way. So that tends not to be a very good way to do it. So what I'll tend to do instead is actually think about having a couple of different sections that are very useful for me for aligning these things. And let's talk about sections that would be useful. When I'm connecting these things, the enemy is being slightly out of plane. Okay, so if you're in plane, you'll get much better connections, it'll line up properly. So if I want to connect these ducts in from the side, a plan view is going to be useful for kind of getting it aligned center front to back. Okay, in terms of aligning the heights, a really good view would be a section that cuts through sideways. So cuts through the building and looks at it like dead on from the side. So that's always a highly recommended thing to do. And if you go to, for example, the HVAC plans, a really useful view that I highly recommend creating for yourself is going to be some sort of section. So I'll say view, and I'm going to cut a section, and just cut something that does, something like this. And again, the reason I want that is it's just going to be much easier to operate if I have something that really is looking at it dead on. So often I'll create a section view that looks like that. Occasionally, though, I'll also create a section view that goes in the opposite direction. Okay, I could do that with an elevation also, but often a section is going to be useful in the other direction for seeing if I have it lined up dead on kind of from the end as opposed to from the side. So those are two section views that are going to be useful to me. And if I click on this one to open it, you'll see there's my little air handler. There are some ducts that are coming up to it. Now you'll notice my ducts that are coming up to it right now look kind of wimpy right now. It's a single line representation of the duct. That's because we have a coarse level of detail turned on. If I actually want to see the true kind of duct lengths and widths, I could turn on fine and medium. It's a little bit closer. So you sort of get a sense of what we're up to. So let's start by just making the ducts that come out of the unit. It's always useful to go through and have those first pieces just kind of hanging out and then try to connect things to them. So if, for example, I wanted to think about the piece of ductwork, which is going to come out of the nose of the unit, over here on the right-hand side, let me zoom on in there. What I can do is create a duct and pull out just a hair. Now even here, it's sort of messing up a little bit on me because it knows it's 44 by 37, but what's happening is it's rotating it the opposite way in terms of the height versus the width. So the reason it's 44 by 37 is that's one of the parameters. That's the parameter of the opening. So it's kind of got it shifted over on me sideways right now. If I choose that, let me show you what it did in 3D. It kind of made it expand up and compress in where I really just wanted it around the other direction. So different ways of handling that. You could go ahead and over here just change it. So it's 44 by 37 tall. So I don't even have 37 in there, so I'll have to just type it. Okay. Now it's squared out. Or the other way to handle that would have been to come back over here and just do it in the floor plan view. Or maybe do it in the ceiling plan because I'm looking up at it. Floor plan on the roof. Just want to see it. There it is. So again, just pull on out and you start to have something. Now, as you're pulling out, if you want to change the size as you're pulling out, you can, as you kind of click on one of these guys. That's a 48 by 48 coming out. You can change it just by changing the values right up here as you go. But I'm going to go back to that section view again because I'm going to want to pull out the one that goes up and out. So So zoom out here. What I'm after is this one up top here. That's where the supply air is supposed to be coming back in. Or the recycled air is supposed to be going back in. So what I would do is kind of pull that straight up. So go ahead and grab that 16 by 42. This time it actually looks like it's doing it the right direction for me. I'm just kind of going outside of the zone, outside of the crop region right now. So I'll just pop it up there. Zoom to fit. So I got stubs, and stubs generally are a pretty good starting point. So here's what happens once you have those basic stubs. From here on out, you have to imagine going through and putting the correct series of reducers and connectors to make that all fit together. And again, it'll do its best job that it can, but it doesn't always do a great job in terms of what it thinks is available. So from here to there, for example, I'm not really giving it all that much room. So in order to make the reduction between here and here, I might want to back that duct off a little bit just to allow a little more elbow room to make the connections that it thinks it wants to make. Now, as you are going through and making the connections, different things that sort of work better or worse for you. If you align things so they're perfectly aligned up on center, it tends to have an easier time because, again, even being off like an inch or two is enough to make that it's a weird connection to go ahead and have to make that transition. So good things to think about checking are really, hey, let's go up to that second floor and just really kind of see how this is working. I got a piece of ductwork right here. I have a piece of ductwork right here. If this duct over here is just arbitrarily, you know, might be over there just because that's the way we put it in there. Now I have this funny little zigzag connection, and that would be a little bit harder for it to make. So it's better to try and align these things so they're like dead on with each other because that makes it a little bit easier to make the connection. So I could say, okay, let's go ahead and do a little modification. See if I can grab the center line of that. See if I can grab the center line of that. And if I could bring those together on the center lines, again, that'll make it a little bit easier to make the connection. What really sort of seems to kill this is it's being off by like an inch or 1 degree, or depending on the complexity of your building, it's those teeny tiny differences that give it troubles. Yeah, if it's off by 6 inches, it'll make some big connection between it. But off by an inch is sort of messy for it. Okay. So if we have those two and things are looking pretty good in there in alignment with each other, one thing to try doing just to see if it'll work is actually just try connecting those two together and see if it will. So if there's enough room and you think you got it, go ahead and just try pulling that in there and see what happens. And if you are lucky, and it can make something out of it, it'll put some sort of connector in there, and it'll do okay. Now, it looks like a very big transition right now, but I'm just betting after I resize my ducts, this one coming in is going to be a little bigger, so it's not going to be quite so bad. This will tend to work okay, unless something turns inside out. Okay, if this pipe actually ends up being, or duct ends up being bigger than the connector, then I might have to resize it to be a bigger unit. Okay? Or do something to change the opening over here. Again, realize though you can also change the opening on this. So for example, it has this parameter over here, this is supply air out, the width and the height. So if I wanted to change that to be 40 inches or something like that, that's actually sort of interesting what it just did there. You see, it actually made a little reduced pipe coming out, and then it's transitioning up to that bigger piece right there. Okay, so probably better to make those changes before you get going. So this one's not too awfully bad. Oops, let me redo that. And I'll do it again. You could try to do this in 3D. 3D I always find to be a little bit dangerous in terms of just making it work exactly the way I want. So I'm going to go through and see if I can find, if I can even find that section view here. Probably there under the question marks. For these section views I created, some people have asked in when we're meeting in office hours, what do these question marks mean and how come things are in the wrong spot? And the reason is every view has a discipline and also has a sub-discipline. So they're known as mechanical, but they don't really have a sub-discipline. If I want to push them into HVAC, I'll choose the section, and I'll choose its properties. That sub-discipline, let's see if I already can find it. It's over here somewhere. Discipline is mechanical, sub-discipline right there. HVAC, if I do that, it'll push it into that section of the browser. So if you're having things in funny sections of the browser, just look at the discipline and where the sub-discipline is. Pop it on in there. Okay, let me go back into the first one. Oop, I think I put it in the lighting by accident. HVAC. That looks a little bit better. So I did it in the plan view. I could just as easily do it here in the section view. Come on over. Doesn't really matter whether you bring one to the other, or actually, this is a little interesting. In this view, it's actually a little bit harder because they're not aligned up and down, kind of at the same location. Fix that for me in the when I was doing it from the plan view. From this view, if I was going to try and join them here, I would probably align them vertically. So let's see if I can get those. And then try pulling that out. Oh, what happens is when I'm doing the alignment, let me back off. When I choose the align tool, generally if you're right dead on to something, you'll be able to get like a center line if you hover over it. You might have to get that. If you can't get that, there's something about the view that's a little skewed. There's some reason you just can't get to it. But let's go and try connecting those. Now, where this connector actually put it sort of seems like it split the distance. If you want to go ahead and move it, that's okay. You can kind of move things back and forth. So if, for example, I choose that, sometimes I'll use the arrow key and just shove it over back closer to the unit. And there we go. So we'll say zoom to fit, or let's like to look at it in 3D. Take a look at it there. So this one's not actually too bad to connect together because we're sort of about the right level. Everything's kind of pretty good. This one over here is a little weirder though in terms of what's going on because I'm coming in around the roof level. I actually need to hook up and like put a big U at the top to go through and connect that. So again, we can try to connect it all in there together. What I generally recommend is see if you can get as close as possible to what you need, okay, and then like do the final connection. So here's what my strategy is doing for this one. For this one, I'm thinking what I'm going to do is over here, based on the one on the left-hand side, I'm going to pull that out a little further than up, like I'm sort of making the U for it, and even come on over, and then finally do that join kind of with as little kind of imposition as possible. If you can kind of guide it as much as possible to tell it where you think the duct should be, it'll generally follow your guidance, and then you can let it figure out just the last few bits. Yeah, so it's a little bit harder to kind of get all that stuff together. Let's see if we can make that work. Actually, let me even try something else. Well, I'll do that, and I'll show you, see if we can make a shortcut work. Let's come over to this section. Here I got my section kind of hanging around. So here's what I have in mind here. I think that I'm going to, from this duct, actually come in and like start to just building the connection back over to where that is. So if I come over here to systems and I say, let's put in some more ductwork, I have a couple of neat choices available for me. There's the ever popular automatically connect. Automatically connect is actually a good one because that is, if I come right over here, it'll connect to the end right there, just fine. In terms of the size of the ductwork though, let's make that match too. What do we have here? About 12 by 24 on this one. So for my new piece of ductwork, see if I can get that same sort of, 24 wide by 12 high. Automatically connect. Let's see if we can make this work. I'll come up. Looks like it's actually just putting a little placeholder in there, but we'll see here in a second. It's interesting. What I've done is I've actually placed a duct placeholder. When I said systems, I must have sort of like chose that instead. There's duct as opposed to duct placeholder. Duct placeholders are just the lines that are going to eventually be connect to that. If you want to convert a placeholder, you just choose it. Okay, so moving along. In terms of thinking about whether this is going to be able to connect together with that piece there, there's a couple things I need to do. I need to go through and it's probably going to change its size because this is bigger than that one right now. It also, since I'm using elbows, has to leave enough room for the elbows. So I need to get enough room for the reducer as well as the elbow in there. Okay, so you can try to connect that together and see how that works. If you're lucky, it'll work. If it doesn't work, no worries. We'll go through and kind of fuss with it a little bit. But I want to connect this one to this one. A really good tool to think about using for connecting these is the trim tool. You might remember trim from all the different line operations when we're cleaning up lines around floors. But I can try trimming those. And in this case, I was lucky. Although just barely, I'm not sure if you can tell, this reduction, there's just barely a little bit left hanging over there. So that was pretty close. But let me undo it, and we'll try it a little bit differently. If I'm worried or it doesn't have enough room, what I can do is just take this duct and push it up for now. I'm just going to arrow it up. I can also just move it up. But what I'm doing here is a technique I sometimes use when I have trouble getting these connecting. It's basically move things out of the way and give yourself a little elbow room. Because then, if you connect it together, you can always move it back. So I'll trim. Okay, I have enough room so I can do it. So now I can go back and move this down a little bit and get closer still. In the same sense, this one over here, it's probably out further than I really want it to be. So I can pull it on in here. But don't be afraid to connect things sort of far away before you get going, because sometimes you just need that elbow room to go through and make all the connections the way you want. So this is the whole idea of really just giving yourself some space. Allow yourself to sort of have some space to operate. So air handlers on the roof are actually sort of a pretty common operation in terms of doing something like this. I'm going to try one other sort of like variation on this theme. I'm just sort of curious about something, whether it'll work or not. Because just sort of based on how it works in plumbing, I think there might be a possibility. Actually, I'll try it down here. Yep. Let me show you another way to do this, although it may not be smart enough to make it work right off. I'm taking off those extra pieces. Okay. Whenever a device like this has inputs and outputs, you often get this choice called connect into. And connect into is basically going to say, hey, I've got inputs and outputs. Choose which input and output you want me to use, and I'll try to connect it to something automatically. And again, whether it's going to do it or not really depends on just how much room there is and how smart it is about how it's going to do it. So you can try just to choose it and say connect into, and I'm going to do the supply air right here. Actually, it's the return air, excuse me. I'll try to connect it there. And not too bad. It put the reduction in a different spot, but that's sort of its guess about how it would do it. But you can often do these kind of connect intos, and that'll work. Let me try it on the other side too. So if you got room, and again, the key to all this is making sure that you have room and that you're properly aligned. Because even if you're, well, let's just even try to demonstrate that. If this is over, I'm just going up now. That's not very good. Let me try just shoving this over in the floor plan view, just a little bit out of alignment. So here I am. Now I'm perfectly aligned right now. But if I was over here, you know, just that much. It doesn't seem like a very big difference to me. You ought to be able to make that. But as we go through and I say connect into, and I'll do the supply air, looks like the big one, out. Okay, did it. I'm actually sort of surprised it was able to make that one. But it's got sort of a funky connector right there. So it might be better, instead of doing that, to go through and just align them up again. So again, what I'll do is go back to the floor plan view. I'll say align. Even get the center line of this to the center line of that. And now I can choose this guy and say connect into. I'll go from that connection over here. So super. So air handlers, they're not all that bad. It's just usually a matter of kind of getting it all kind of positioned properly so you got things in place. This is an air handler that is designed to be outside, but they got a lot of other air handlers that are also available. Let's kind of grab another one in here. Let's say, we'll just insert another one. Let's load a family. You'll find them all. Where they live is out there in the library under mechanical, MEP, air side components, and they have a bunch of different types in here. We have all sorts of kind of individual pieces, like coils and front discharge units, and they have these big sort of mixed ones. That's the big outdoor one that I used right now. There's another rooftop one over here. That's just the coil. That's a fan, a filter, all these different pieces, the mixing box. It's an indoor one. Let me go to this vertical one right here. It's actually not a bad one, but we'll kind of take a look at it. That's a giant one. Let me go for the slightly smaller ones. Notice they're rated 6 to 10 tons, or 12.5 to 25 tons. That's going to be related to how much heating and cooling capacity they have. Let's see what I got. I'll go through and put it out here. It's a piece of mechanical equipment. So we'll just set it out over here next to the building. Now, even for this vertical one, kind of hanging out over here, let's take a look at it. Notice that it also has ins and outs. You'll see, what does it have here? Here's what's going on. It's got water coming in and out of it. It's got electricity coming in and out of it. It looks like what's going on here. It says they're both out right now. That confuses me a little bit. So what's going on? It shows the in coming in over there. Okay, that's like the supply air in. We gotta think about this in terms of how it all works. If I open it up, you can sort of choose any of these different connectors. So let's see what this one is. That's basically supply air out. Okay, that's going back into the building. That's supply air. That says supply air out also. Why are you both there? Try this again. Supply air going out. Supply air. It says flow going out. That actually confuses me. What's going on over here? This says return air in. Okay. So that's a little strange, but I think that what's going to happen is the return duct is going to be coming in here. As I look at it, though, it looks like those should be the supply and return over there, but I don't know. I'm going to trust in what it is. So if you want to connect one of these, what you'll do is it's kind of the same sort of situation. If I wanted to connect this guy down here, and I was connecting it to the supply, let's say, for example, the supply we decided was going to go ahead and service that part of the building. But we were going to break off the supply somewhere over here for this other part of the building. Maybe I can just split that. Okay, so I got a nice piece of supply just waiting to be connected over here. Got a little connector there. Great. What you can do is, again, choose this guy. Say connect into, let me do the supply air. Figure out which one it is. And it'll do its best to go through and connect it in there. Okay, so it's not bad. This is kind of all working with how you might go through and place it and ultimately distribute it. Realize again that what's going to happen is as the ducts get bigger and bigger, making these connections is going to get harder and harder. And it's just they get bigger and bigger in terms of how much space is involved. So it's always good to sort of put things at a fairly local location, but it's quite common in many of your buildings. For example, if you have a 2 or 3 story building and you're thinking about a single air handler that's going to be up on the roof or something, what you can have is basically it feeding a vertical kind of duct, and then have that connect down to the different levels. And let's kind of demonstrate that sort of strategy. See if I actually have this in here. Let me see if I have a multi-floor one. I think I may. Basement, exterior. Nope. These are all just different variations on where you might actually put the air handler. So for example, this is the idea of a mechanical room that's just kind of off on the side of the building. This one's actually outside right now. Let's see what we got going on here. In this case, what I have going on is I have these ducts on the first floor right now. The air handler is actually right inside this area. So let's go ahead and take a look at that. I have a nice return duct coming in. I have a supply duct coming out. They're kind of over here in this kind of mechanical room space. In this mechanical room, which is down on the first floor, there's a louver that's basically allowing the cool air to kind of either come in and be used as the return air. I can also exhaust out through a set of louvers, so it's okay to have it on the outside of the building. You don't want to have it on the rooftop. Okay. This is actually a pretty good example to start talking about how you actually handle multi-story spaces. Because, again, if you are thinking about a multi-story building, very often the system on the first floor and the second floor will be very similar to each other. What will happen is we'll have some space which is like a mechanical core shaft where things will come up and down and then connect the various floors to it. So let's kind of think about how something like that would work. So just to sort of take this example and adapt it, here's what you can do. Let me go over to the elevations for a second. See what's going on over here. Imagine, as opposed to being a single-story building, this is actually a multi-story building, as some of you may have. What do I got over here? Let's look at it from the south side. I got level 1, I got level 2. We're going to add a level 3 to this. It's going to add another level 12 feet up. picture the building getting a little bit taller. Okay. What you will very often do is take all this work that's kind of hanging around in here, okay, and just copy it and paste it aligned to another level. Let's see if it's on level 3. The question is whether it's sort of based on the bottom or the top. Let's see what it thinks it belongs to. No, that was up a little high. Well, that's okay. We can paste it on level 2. We're going to have a multi-story building here. I'll paste it aligned to level 2 also. So here's a really common situation. I got a multi-story building. I got all that stuff going on in there. You say, how can we connect them all together? And usually the way it'll work is we'll have the systems on the individual floors, okay, but then we'll go through and somehow connect them together with a vertical shaft of some type. So how we can do that is if we zoom on in, you might notice right on down here we have this nice little multi-boxy looking unit over here. That's a little like multi-sided connector. It's just really a two-sided connector right now. If I want that to be three-sided so we can go on up and kind of continue out the top, what I can do is go ahead and open it up at the top. But let's do this the other way. Let me do it in this section view because that'll be a little bit easier to see. Again, what I'm interested in doing is I want to create a section just so I can see all these things. So right about there. Square it out. Let me turn up the coarseness or the fineness so I can actually see those ducts. So there's that little blue duct coming around right now. And what I'm interested in doing is as follows. As opposed to just going through and just having that being all just capped off like that, what I really want to do is extend that up. I'll zoom on out. So I'm just extending it on all those different levels. Actually, up above, I already had that little connector there, so I'm going to take it out. Just because that little connector is going to be one that I want to replace with sort of a multi-ended connector. I want a nice open end here on the end. So bring that up. Now we're ready to reconnect all those individual subsystems to it. So the way to do that is up here on the upper level, if I look at it in the section view, I want to just go through and do a trim there to make the L. Okay, so if I look at that section, I'll zoom on in here. If there's enough room, let's see if there is enough room, since these are little kind of square connectors. That ought to work. Okay, that did pretty good up there. As you go moving on down the building, you have this little connector right here. It's kind of right next door, but it's not actually connected in. So what I'm going to do is pull it until it connects in. Do the same thing on the second floor. So you can join them all together. That looks like it still has a little leftover on the end. So now we actually have a pretty good system that looks like it connects all the different floors together. Great. So that's a very kind of common arrangement. So the whole idea that you have a mechanical room that is aligned on all the different levels, which then gives you the ability to kind of run some duct up between all the different floors and distribute out from there to all the endpoint locations, is typically a really smart way to do it. Because you like a nice, clean, kind of just to add a note of reality to all this, what's going to happen is, as we size the ducts, things are going to keep on getting bigger as you go all the way down, because if this size is big enough for one floor, you can imagine twice the volume on the second floor, then 3 times the volume down on the third floor, as it's all kind of chaining in there. So these ducts, if I size the whole system, you get bigger and bigger as they come back towards there, and it probably need a bigger air handler down there at some point. But at a high level, that's what it's sort of doing. That kind of makes sense. I'm kind of checking with you. So the big thing with air handlers is kind of figure out where they are or where they want to be, try to put them in a very central location, and then try to connect them. And if there's any one thing that'll just give you a cat fix, it's going through and trying to make that little connection. Because if you're just off by a little, a lot of times you just have a lot of trouble kind of connecting it. So aligning, or even like what I did there was actually, you know, pretty brave in terms of being there, or foolhardy, might have been a better description with it. Often what I'll do in a case like this is just temporarily, I'll just move everything out there and make the connections and then shove it back in the building, because it's just easier if you have more elbow room. So don't be afraid to do that in terms of just kind of clearing yourself some space. Okay, so that is air handlers. Let's talk about how all these things actually tie together into a system, because then that gets into the whole issue of like how we calculate things. Mr. Lucas, what you got?
So with systems like this, is it uneven for each floor? How much air ends up passing through the ducts on the third floor versus the first floor?
What'll happen?
For really tall buildings, would you have multiple air?
Yeah. Ultimately, at some level, you know, if the pressure were all even, it should balance itself out. But the more and the further you get away, you know, all our perfect assumptions somehow don't work out. Like, so even though theoretically it's all balanced so that even the end point gets the same sort of like delivery as what's happening on the first part, yeah, it isn't realistic. So we typically will divide it into subsystems. So even in a system like this, if it was a really tall building, like, you know, a single air handler holding 2 or 3 floors is probably fine. You know, if there were 7 or 8 floors, you'd probably think about several different air handlers and splitting the load up a little bit. Or even what they did here in Y2E2, which is another valid way to do it. Yeah, our building's kind of strange. You can sort of think about all our atriums as being different zones: the red zone, the blue zone, the yellow zone, and the green zone. So there's different air handlers on the roof that are handling different subsections of the building vertically. So since it's all up on the roof, they didn't have the ability to put them in the middle somewhere. They split it across the roof, so they have, you know, the north end and the south end. Okay, which is often kind of a reasonable strategy. Let's just kind of talk about that. As you think about this multi-story building, and you think about the north side versus the south side, and my little dumb building here doesn't really matter very much. But if this were all sheathed in glass or some commercial office building or something like that, you might imagine that, oh, the first floor is probably a little bit different than the upper floors. If there's commercial and a lobby and stuff like that, it'll be a little bit different. The second, third, and fourth floor may be very similar if they're all office spaces. But even there, the offices on the south side, which get sun all through the day, are on the west side, are probably a little bit different than the north side offices. You know, so we'll often sort of break things up into different zones so that it could be that a different air handler is handling the different zones. It could be that we just take a single air handler and we break it up with these little subdividers called VADs or something like that to kind of break it into zones. So there's a lot more we can do to it. But it is fair to think, yeah, it's very rare that a single air handler kind of takes care of the whole building. Or if it does, as you sort of suggest, yeah, the poor guy up on the third floor in the back corner is, you know, either he's suffering because he doesn't get enough cold air, or the poor person sitting right next to there is probably freezing because somehow they're getting a lot more air than they should be, because you do have loss as you go through the pipes. Okay, so all these things at some level you think about as being a system. I haven't really talked about it that way, but they really are a system. And even though we haven't really thought about it very explicitly, it has actually been aggregating. Revit's been aggregating all these things into systems. So that's kind of like one of the next concepts you need to think about. There's just this whole notion of systems. And as you look at that right now, there is at least one supply air system and return air system. Actually, there's probably 3 separate return air systems, but I haven't connected them all together yet. But if you want to keep track of the systems, here's what that looks like. Under View, in the user interface, you can turn on something called the System Browser, which is also function 9. I wish I had a button that made it a little bit easier to see. But there's this little browser that'll show you the different systems. So I have some different systems here. I have 4 different mechanical systems. On the return air side, it looks like I have 3 different return air systems. On the supply air side, I have 1 big supply air system, okay, that has all those different diffusers. So on the supply side, since I connected it all together, you notice there's a big system. Let's see if I can spread these columns out a little bit. You'll see that all the different diffusers right now, or the terminals, all have 500 CFM. So altogether, this air handling unit is able to handle 2,400 CFM. Actually, is that right? 1,200 CFM, 2,400, 12, there's 24 of them. It looks like that way. Okay. Nah, something seemed odd. There's 500, 2,400. Oh, that's actually. Yeah. My air handling unit's a little undersized right now, where it needs to be. In this whole mechanical supply air system, there's really 12,000 CFM. That seems a little bit closer to what's actually coming through here. This air handling unit isn't actually adequate to go through and handle all that capacity right now. So that means I need to come up with a bigger air handling unit. So this little air handling unit, you'll see it has its own sort of capacity in here, nominal capacity. That's its heating capacity. Let's see if we can find its flow. Mechanical airflow about 2,400 CFM. So I need to get something bigger. So I might be able to find another one. 4,000 before I get myself in trouble. Okay. So that'll be a little bit better, but I'm still undersized. It looks like I have to go shopping for a bigger air handler if I'm going to go through and try and tie it this way. Or I can put 3 different air handlers and split the load amongst them. Okay. Notice the air handler does have, though, not only a flow, but it also has some sort of capacity in terms of BTU per hour. That's going to get into the amount of heating and cooling and whether this thing can actually go through and take care of all the heating and cooling that's necessary. So kind of a balance of figuring out the right size and how to make it all together. But ultimately, it is all being tracked as a system, so we can kind of keep track of really how we're doing relative to our needs. These 3 different mechanical return air systems, they're separate right now because I haven't connected them together physically. If I connected them all and they would connect back to the air handler, they'd have the same problem. Okay, sort of makes sense? Okay, beautiful. For the most part, think about where you want your air handlers to be, and as you think about where your air handlers are, go through and take a look at. We have them outside, we have them in the basement, we have them in the roof, in exterior pits, we have in exterior walls, you have in a mechanical room, you have a bunch of different variations. Take a look at them and sort of see different ones and think about where you want your air handler to be. But if you have a mechanical room, that's not really a good place for it typically. Okay. If you have a mechanical room on an outside wall, we can put vents right in the wall of the mechanical room. If you have a mechanical room on the inside, we may have to sort of run a return air duct up through to the roof or something like that to either exhaust the air or bring fresh air in to the air handler. Here, I just put it outside. Okay, so it all starts with these air handlers. You sort of connect them all together and these systems. But then we get to the whole issue of how much heating capacity is actually needed to tie this all together. And that's where zones and spaces and all that come in. This is where it all kind of comes back together. So in terms of heating and cooling, there's kind of 2 sides of the equation we want to talk about. We want to think about both, in terms of heating and cooling, sort of the alternatives about how we provide it, as well as kind of the source of the heating or cooling and really what those loads are going to be. So let's think about, as well as what the demands are. There's really, I guess, 3 things. So within this, as I thinking about heating and cooling, we always have, okay, the demand. Okay, then we have the source. Or how we're supplying it. And that's going to get into both sort of the location of where we're supplying it and what medium we're using. So let's think about heating and cooling for just a minute. In terms of the demand side, like let's think about what actually affects that. So as you're hanging around and you're in this building on a warm day like today, with the air conditioning on like this, sort of what actually determines the amount of heating and cooling we need inside this space? Yes, Mr. Carl, what would you suggest?
Sun.
The sun outside is actually having a big impact in terms of what's going on over there. It's sort of putting a lot of radiation through all those windows on the south side. It's also heating up the air outside. Okay, so yeah, this whole outside climate and the sun is having a big impact about what's going on. Okay, the basic equation is kind of like this. See if we can kind of make it happen right here. At some level, we're kind of hanging around inside of our room here, and that's my time. There's this range of, we talked about it before, it's sort of a comfortable zone of temperature that you sort of like it to be. There's sort of a lower limit and an upper limit, and this is kind of considered my comfort zone between here. And so it depends on our set points in the building. Typically, in a building like this, if this room is more than, probably 76 or 78 degrees, you're probably going to start saying it feels a little bit warm in here. Okay? So there's this upper limit. I'm going to say that is my cooling set point. If the temperature ever gets higher than that, I'm going to turn on the cooling. On the other side, I have the heating set point. So if it gets colder than 68 or 66 or something like that, on the other side over here, you're probably going to want me to turn on the heat, because you want to stay within that comfort range. So what happens on a warm day like today is, as the outside temperature heats on up, and it's up closer to 90 degrees today, what's happening is we're a little bit insulated from that, because what happens is all that insulation in the walls and all the air that surrounds us sort of buffers us a little bit, so we don't actually feel the 90 degrees. We're kind of lagging a little bit behind that. So we're probably down in here somewhere, because we are a little bit insulated. Okay, but because the temperature that it would want to be higher, we're going to turn on the cooling to go ahead and kind of make up that difference and bring us on back down. Okay, so that's kind of basically how it works. So it is affected by the outside temperature. It's affected by the insulative properties of the walls and the windows, because that will determine how much buffer we have between us and the outside. It depends on how much people open and close the doors, because if they open and close the doors a lot, we're losing a lot of air. It also depends on us, because believe it or not, I actually generate a lot of hot air. You do too. I probably do more than you. So all that hot air that from my waving around up here is actually, I'm putting off heat, you're putting off heat just by sitting there and kind of being attentive. These computers are putting off heat, these boards are putting off heat, there's all these internal loads that are putting off heat. So all these things get added together to sort of say that, hey, we have internal loads, we have the external loads, it's trying to heat up all this air, we're trying to keep the air cool, and then we try to make up the difference. So that's kind of the theory behind it all. In terms of where that all plays out, it's back over in Revit with the whole notion of spaces. And I think a lot of you have been playing with spaces in terms of trying to make this work for your buildings, and it plays out like this. Let me kind of put my system browser away for right now. The other is I have these little spaces. These spaces are very much like rooms. And in this model, I have a couple of different spaces here. Here's space northwest. Again, the big thing that sort of determined how it's going to perform is we have the whole idea of It has an occupancy, like, or space type, they call it here, classroom and lecture sort of space. We have the notion, is it heated and cooled, heated only, cooled only, naturally ventilated? We have a lot of different choices in there. Unconditioned, it doesn't want to be conditioned at all. Vented only, naturally vented only. Okay, so we've got a lot of different choices in there. For some spaces, for the spaces where your people are occupying, they'll tend to either be heated and cooled, or some combination where we can go try and supply some of that stuff using as much of the natural heating and cooling as possible. You know, occupiable is the big thing there. You know, for things like my little mechanical room over in the corner or something like that, that you can actually turn off as unoccupied because you don't really care about heating or cooling that. You know, the heat that's there is actually going to probably just exhaust right out through the vents. So it starts with a condition type. Within those different conditions, there's all sorts of calculations that happen that based on the fact that it is a classroom, there's a certain number of people which are calculated in there. If you know that you have a different occupancy or you have a different heat gain value per person, because as opposed to doing what we're doing in here, which is kind of like watching and kind of observing, if we were all doing aerobics or dancing around, we'd be putting off a lot more heat, so we can go through and change those values and up it a little bit if the occupancy is a little bit different. Okay, within the whole notion of spaces, there's also the idea of different sort of power densities. For each of these different spaces, there's sort of a default area per square foot, sensible heat gain per person, latent heat gain, the lighting power density. And because we're in a classroom, it's somewhat bright, but probably not as bright as it is in like a retail space, something like that. So we have a lot of different sort of things that are all determined by the spaces, and it starts with the spaces. So that's going to take care of the internal loads and how that's coming together. What we tend to do is we take our spaces and we aggregate them into zones. And zones are all about, well, if these two rooms want to have the same, basically, thermostat or control system, so if heating and cooling turns on in these two rooms, it's only in these two rooms and not those two rooms. Okay, we'll make that a zone independent. If there's one zone for the entire building, then if the air is blowing anywhere in the building, it's blowing throughout the building. So zoning gives you a little bit finer control. So we can put thermostats in the different rooms. I broke this room up originally into this building into 3 zones: the northern building rooms, the southern spaces, and the central hall. And how you do that is under the Analyze tab. First, we create spaces. And then we can create zones. And if you edit a zone, you can basically see which sort of spaces are within it. Although, let me show this in terms of how it did get laid out. If you go to the heating and cooling loads, you'll actually see these are the different spaces. Okay. We have an overall occupancy. That's going to be overridden by the kind of local consideration of what we said for the individual spaces. Then we have a location like Boston, Mass, or Palo Alto, whatever you want. We have some basic idea of what our building service is going to be, whether it's going to be a radiant floor, a hot air system, a VAV system. These will all have a very big impact on the energy that's actually sort of assumed. So I'm going to do VAV system for right now. Okay, I'm going to leave the building construction out of this for just a minute. Save those settings. Come back in there again. Under the details, you can actually see the different spaces broken into zones. So what's happening here is these are the individual spaces. You can get a little about the construction of each of the individual spaces, as well as the people, the lighting loads, and all that type of stuff. They're kind of currently in zones. Looks like I actually moved my space northwest out of the north side rooms space, so I actually want to put that back in there. The important thing to notice here, though, is you want to make sure that these green boxes that are floating around here are sort of well-defined and you don't have any little exclamation points next to them. Because exclamation points mean that something's a little bit wrong in the analysis. So let's see if we can kind of demonstrate that. If I come over and as I'm defining my spaces, if my spaces aren't quite tall enough, okay, what'll happen is you'll get an exclamation point because they won't be bounded at the top. So for example, this is going up to 10 feet. You go ahead and just lower it down to 8 feet. It might have been there as a default. But if I come back over to my heating and cooling loads report now, see what's going on there. Okay, notice that one has that little exclamation point. That little exclamation point means there's just something that's not right about it. There's a warning associated with it. So it's not bounded by a roof, a ceiling, or a floor element. This can result in kind of inaccurate numbers. Okay, so always check that. Make sure your spaces are bounded properly. Let me come back over here. I'll fix that. Use my space. I'll put it back up to 10 feet. Okay, I can go back to that report again. Now it'll be okay. Okay, I'd like to get that actually into the other zone. Looks like I'm going to have to edit my zones. See if I can make that work. If I say zones, what I want to do is add it to the zone. I don't want it to be in its own separate zone. Maybe I'll do this. Come over to here. The zone editing is always a little mysterious to me. Let me go to systems there. Oh, analyze, excuse me. Let me edit that zone. I'm going to just add a space to the zone. Okay, now it's together. I just pulled them back. Hey, that doesn't look good. I think this is going to warn me that basically there's a zone with nothing in it. We'll see what's happening there. This zone has been, well, I sort of got that. I'm going to get rid of my zones. What I'm going to do, that is probably something a little strange to do, but it'll work, is to go through and create a zone schedule. Looks like I have some zones here. There's nothing computed right there. So what I'm going to do, you can sort of see which ones currently have 0 square feet or 0 occupiable area in them. I'm going to just take out the ones that have the 0 in them because those really aren't there. Delete the column. How do I delete a zone? That's interesting. A zone that's not really there. Go back to my zones again. If I were a zone and I wanted to, let's get out of this view. Rid of that. That's basically a new zone right now. Cancel editing the zone. I'm trying to think about how to basically get rid of a zone that doesn't have anything in it right now. And I'm wondering where in this fabulous Revit interface I could actually do that. It's not in here. I'd sort of like it to be here and be able to delete that. Can I do that? Let's just isolate. Select all spaces in the zone. It really isn't there. So let me think about this. If I can't get rid of it in the zone schedule, I can hide the column, I can do all that, I can't get the row, I can't get that. It's interesting. Can anyone have any idea, like, as we're doing this? Because I'm just I'm fumbling trying to figure out how to do this.
They're letting you delete all the rows except the top one.
Is that it?
Yeah.
Let me give you that one. Oh, that's actually pretty nice. Oh, that actually makes sense. In a weird way, this notion of default, which doesn't have anything in it, okay, it does have to keep that around. It's sort of a default zone at all times. Okay. Let's get rid of some of these other ones. Okay, so over here, let's delete that one. That actually makes sense. Okay, north side rooms is just formerly the north side rooms, but no longer there. Thank you. That'll teach me to go to the first one, as opposed to diving right in. Okay, super. So if we come back out here, we have our different zones. We have square footage in each of our zones. You'll notice we also have set points, cooling set points and heating set points in each of our different zones. So if it gets less than 70 degrees, we're going to heat the space. If it gets warmer than 74 degrees, we're going to cool the space. Seems like a very tightly controlled building here. This building, I imagine, is going to actually go through and use an awful lot of energy, because to kind of get the set points that narrow is actually a very narrow range. Well, let's just try it and sort of see what's going on. We're going to say that we have the cooling air temperature coming in at 54, the heating air temperature coming in at 90 degrees. We'll go through and do some calculations and sort of play with those and see how big a difference it makes. So let's go ahead and do this. Let's take our break for right now. When we come back in 5, we'll play around with these zones and do some calculations to sort of say that given these different zones with this amount of space and these heating and cooling set points, how much heating and cooling do we need? And then we'll play around with the temperature or the thermal properties of the walls and see how big a difference that makes too. Okay, so let us break and come on back.